Welcome to a lesson with Dr. Powell. Let's take a look at how we can solve a fun puzzle. This is a group operation table puzzle. What does that mean? So just like you have maybe an addition table for whole numbers, positive, negative, and 0. So say you have something like, but I'm just going to write out, of course, there's infinitely many, so we'll just write out a few. But if you had something like this, you could fill out an addition table like this. You could say, okay, I know that 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 2 is 2, and so forth. You could just kind of work through this and fill it out. But this is a little different. I mean, these are letters, not just those numbers. They could represent different things. And this operation, it might not represent plus. It could represent doing maybe if like these were some kind of transformation you could do in an object, like a rotation or reflection or something. This means, hey, do this one, then do that one. And the result is another transformation. Which one is it? That's kind of one way to think about it. So it's kind of like a mathematical group is something of the sort. It doesn't have to be a nice addition. It could be something like that. And there's certain properties that go along with that. And those properties can be fun in a puzzle form, okay? And it might even help you understand what those properties are, where they come from, and what we can do with them, all right? So let's take a look at what we're doing here and think, okay, so we start with this and somehow we're going to get this. So with a mathematical group, the first property that we look at is, we could say the first property is the fact that we could just fill out the table, that there's going to be, we can fill it out with letters. That's called the closed property of a mathematical group. Okay, if this set A, B, C, D, E, F were the group, and this is the operation between them. So we take a letter, like we say, for instance, F plus A is D. We could write that down, like F plus A is D. We could write that, okay? And then we could do, or we could do something like B plus F. So B plus F is D, and F plus B is E. Oh my goodness, look, F plus B and B plus F are different. Order will matter here, and that actually is quite true if you're dealing with transformations and not just adding regular numbers together. Okay, so we'll keep that in mind as we go. But, all right, so that's like the first property. We can just fill out the table and we know kind of how it works. The second one is the fact that we have an identity element, something that behaves like 0. So if you add by it on one side or the other, it's going to be as if nothing happened. So if you notice, just looking at this table right here, let's just look, is D plus anything itself? D plus C, so C behaves like 0. So every time we add by C, it's going to do nothing. Like A plus C is A, B plus C is B. We could just fill this out. A, B, C, D, E, and F. Okay, and likewise, right here, 0 plus anything is going to be itself. So we say like A, B, C, D, E, and F. Okay, so we've just identifying which is the identity, meaning like the 0 guy. That helps us fill out a bit of the table. All right. Another fact that we're going to use in this process is that we have to is inverses. So just like, if you add 2 plus negative 2, what do you end up getting? You end up getting 0. That is because negative 2 is the additive inverse of 2. It takes you back to the identity, to nothing. So we're going to have that fact. And the way we're going to use that fact is as follows. So we're not going to have any repeats. Notice here we don't have any repeats in the solution here in each row and each column in the interior. So for instance, just suppose, what if A plus B were the exact same thing as A plus C? Well, what if you had the same thing here and here? So that's like saying, like, A plus B is equal to A plus C. All right. Now, if that were true, since we have like a negative, that's like the inverse that we can add on. We could subtract A from both sides. That's kind of what it means on the left. Okay, it has to be, we got to be careful about order. So you'd have to like add negative A on the left to both sides. But since it's right next to each other, we're good. They cancel out. It's 0. But wait a minute. That meant that these guys must have been the same. But we knew they were different, all right? So since all of these guys are different, there can't be any repeats. All right, so we're going to keep that in mind. No repeats, all right, as we go along in this process. Now, let's just erase this right here and keep going. Okay. So, okay, so we're not going to have any repeats. We're also going to have, what do these chunks mean up here? That simply means that our operation table is kind of be like, it's going to be an operation table on like chunks. Like this chunk plus this chunk is only going to give you one other chunk, like right here. This chunk plus this chunk is going to give you one other chunk here. This chunk plus that chunk is that right there. That plus that is right there. These puzzles can get a little bit more complicated, meaning what if I didn't put the chunks right next to each other? It makes it more fun. You still have to work through that. That's a fun puzzle in and of itself. But I wanted, at least for simplicity's sake, for explanation, to show you the simpler case where I bunch them up together. So this means, see in here how we have A, B's, and C's. We'll only have A, B's, and C's. In here, we'll only have E, D's, and F's. Here, we're only going to have D, E's, and F's. Here, we're going to only have C, B's, and A's, okay? So in each one of these sections. That's kind of a nifty thing in this puzzle, all right? So we can start filling these things out, realizing that we don't want any repeats, and we can only use certain letters and certain squares. In fact, we can kind of begin this process right now. So what would go here? What goes here cannot be, definitely can't be E. And what goes here definitely cannot be D. However, let's see, but we have to have, so just looking at this right here, we know we're going to have, so in here, in each, we're going to have an E, F, and D going on here. So we need an F and D, but the D can't go here. So D must go here. Now, why do I know? Because every single one of these rows in here has to have, or columns in this section, has to be E, D, and F with no repeats. All right, so that's how I got that. So then I could fill out these. See how I filled out those right there? That's because I had an E there, and I knew that I had to have a D and F here, but the D can't go there, so I could fill that out. Now up here, it should be pretty clear. E, D, F, D, F. I need an E. I filled that one out. Okay, then we can go right here and we do the same thing. We know we have a C. This one has to be an A. This one would, okay, so A, B, so that must be a C. That must be a B. Okay, so we could fill out that one and that one pretty nicely. All right, next we come over here and we think about trying to fill this out a similar way. We know that we're going to have an E and F here, but we already know the order in this row right here. I mean, this has to be, let's see, hold on. We have to have an E and an F, but this one cannot be E because we already have E down below. So that's an F, and this one must be an E. Okay, so then we can fill this out. So that would be an E in this column. You have it right. Each column has to be the same. So I mean, you have to have E, D, and F. So here we have an E, F, and a D, and then we're going to put an F right here. Okay, this is awesome. Now there is one property of groups that we haven't addressed yet, which will actually help us fill out how in the world do we fill out the rest of this down here. And that is associativity. Associativity basically just means, like with addition, like you can change where the parentheses are in an addition sentence. But one way of looking at that on a group table is kind of fun though. So if we were to find a rectangle that has a 0 in it, like in our case it's C, right? The identity. So for instance, I'm going to look at this rectangle right here. Just look at that rectangle. And whatever goes right here, first added to that guy, D, will be F. So it's kind of like, if that's a question mark, and then I'll just use a plus symbol. Okay, it's star, but I'll use plus. So that plus D is F. Now, how did I get that? I mean, okay, so it comes from the idea of associativity, which it's actually equivalent to it. I won't really put that down, right? Should show exactly why that's true in this video, but we're just going to use the fact. So so we make a rectangle with the identity being in a corner. Whatever's vertical from it plus whatever's horizontal from it, in that order, vertical plus horizontal, will give you the opposite corner. So so right here we have something plus D is F. So what's that something? Okay, something plus D. So D would be going down here. So something plus D is out. Look, it's A right there. So we can fill that in. We know that's an A. Beautiful. Now, since we know this is A, B's, and C's, we can already fill in this right here. We got a B. Okay, because we know you need an A, B, C right here. Okay, now we want to fill out the rest of this. We're going to use associativity again. So we look for another rectangle. Now we could be exploring and looking around, but I'm just going to cut to the chase and show you which rectangle to use so you get an idea of how these are done. Okay, what if I were to use this rectangle right here? So something, no, actually it's over here, right? It's vertical. Vertical plus horizontal is F. So D plus something is F. Okay, so starting with D. So D plus something, D plus B is F. See right there? D plus B is F. That means D plus B, that would go right there. Okay, a B. All right. So I know that this will be, so A, B, C. Okay, then I can begin filling this out. So right here, I know I'm going to have a C and an A to fill out this row, but the A can't go here, it has to go there, which means C is there. Then I can fill this out with a B, and I can fill this out with a C, and I can double check it. C, B, A, C. Was I doing it right? Did we do it right? Did we get it? Looks good so far. Yeah, I think we got it. So we just were successful at solving this puzzle. Notice that I used the associativity idea twice. Okay, so I used it to get this guy, and I also used it to get that guy. The rest of it I was doing using the things with no repeats. Also the chunking idea, knowing that certain parts of this are going to have only certain letters within it. In the study of groups, basically what we're looking at is it's called like there's a quotient group, a normal subgroup lurking, whatever that means. But it's fun, kind of fun how we can kind of have some conditions to generate such a table like this. Hope you had fun with that. And and I have some of these puzzles in my available in my discrete mathematics book, second edition, and I also will have some in another resource as well. I'm planning to make a puzzle book out of these, and um, I hope you enjoy it. Thanks for watching.